Hi again, this is Mr. Ford, and today we're going to be looking at scatter diagrams and correlation, both things that you would have already seen in GCSE, but let's just reiterate some of the really key importance that you're carrying through into A-level. Okay, so we're going to look at scatter diagrams. Now, previous videos have us actually drawing line graphs and drawing axes and being able to plot this, specifically making sure you're using crosses into circles, so make sure you've seen that. Now, what we want a scatter graph for, scatter diagram, both would be okay, is it shows a relationship between what's known as bivariate data. Now, this is just two variables, so two pieces of information, and the job of it is to see whether there is actually a relationship between them, whether there is a correlation. Once we do that, once we've drawn our data in, when we're going to try and actually draw a line of best fit, I'm going to talk to you about how you do that as well. And we're going to be talking about this positive correlation and negative correlation. And there is this thing such as a strong versus weak, but you can see that with the Spearman's rank correlation coefficient in a next video. So scatter graphs. As you can see here, scatter diagrams are used to measure and understand relationship between two different pieces of data. If a correlation exists, you can draw a line of best fit. We have a positive correlation. Now what that means is, as our value here goes up, so as this increases, so let's say we have some data here, let's say this is our x-axis and this is our y. This graph represents the fact that as our x increases, goes up, so does our y. Now this is representative by the fact that our data is going in the upward direction. Now, if we have it the other way around, and as the x is increasing, so it's going to the right, the graph is going down, that would be a negative correlation, because as one increases, the other one decreases. Now, it's really important to note, and this is very important with statistics, correlation does not represent a causation. Just because there's a relationship and there's data to support these two here, just in one graph, that does not mean there is actually causation. Further study must be required. This is very important when we're doing things, especially real world, and just understanding the relationships. So first off is seeing if there's a correlation, and that's really what these graphs are for. There's a little bit more as well. So there's this another point as well, and I'll show you how we do the line of best fit. But if we ever want to predict data, you need a line of best fit. You need a point as which you'd read from the graph. So you'd go up, and then at which point you go left to the other axis or down. So the first thing we'll talk about is interpolation. So this is when we make predictions within the data. So that is when we make any predictions within this square you can see here. This is preferable. And we could say it's accurate because the prediction's accurate because we have data to support it. There's another thing that sometimes happens that's known as extrapolation. Extra, exit. So this is outside of the data, which you can see by this little dotted line here. This dotted line represents a prediction from the graph, from our data. So we've got a prediction here, but we don't have any data to support it because there's no data that say that this is what the graph may do. So this is not actually as accurate, and it is very dangerous to be used and extrapolate a result. You can still do it, but it might not be accurate because you don't have data to support it there. But very careful. And these are things that happen in the real world, and people just do these without actually understanding the repercussions of them. Okay. So what we're going to do is we're going to first, I'm going to be working with actually drawing on the scatter graph and drawing a line of best fit. So what I've done is I've gone and grabbed some actual data from some exam questions that you've done, and we're going to go through them. So scientists investigate a possible relationship between the percentage of fat in the diet and the death rate from breast cancer in women from 10 countries. And you can see these here. Now we can make an assumption just by looking at this data, but what we're going to do is try graphing it and see what happens. First thing I'm going to need to do, and you're going to notice on the graph in a moment, but we need to look at what our lowest to highest value. So our lowest value here is 9, highest value being 40. Death rate of women, so our lowest rate per 100,000, lowest value is 1.5 with the highest value of 20. This is really important. So first off, if we look here, scientists investigate a possible relationship between the percentage of fat and diet and death rate from breast cancer in women from 10 countries. We want to represent this in a scatter diagram. Before we do anything, we need to have access. Now we've gone through this. So I'm going to do, okay, it doesn't matter which one's which, but because I know the way that my graph works, I'm going to make this my x-axis, but you can do it the other way around, and this my y. Okay, now I'm doing this just because I had to extend this graph to make it work. So I'm going to make this my x-axis, so I need to go up to 20, and the other one needs to go just over 40. Let's have a look. Now just guess and check. Now if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is about halfway, so that's going to work. And for this one, I'm going to go up in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and it's going to work as well. I'm going to pause it and then draw these in, but you'll have to do this yourself. Okay, so what I've done here is I've filled in across the bottom from 0, 1, all the way up to 20, and 0 all the way up to, and you'll notice this will go to 42. Now, first my value is, so I'm going to measure, so I need percentage of fat's 9.5, and death rate is 1.5. So percentage of fat is 9.5, which is here, and death rate is 1.5, which is there. So that's going to be right here. So that's that first point. Okay, now we're going to try the next one. Percentage of fat is 15, death rate is 7. So percentage of fat is 15, which is 12, 14, 15 here, and death rate is 7. So I've got this value right there. And what I want you to do is slowly go through and mark every single one. Again, I'm going to pause this, and you're going to get it done, and then you're going to notice that then you're going to unpause it, and we're going to continue. So you can check. Right. So have a look to make sure that this is what you've got, and of course you can pause this and then you can make sure you've done this as well. Okay, I would actually advise you to pause this at the moment and make sure it's done if you haven't done so already. So here you have your scatter graph, you have your plotted points. What's the relationship? Okay, and it's really good to have an idea and have a look if there's a relationship before you even do the line of best fit, because it's going to give you an idea of where the line's going to go. So as your death rate's going up, what's happening to the percentage of fat in the diet? Actually, they're going to be the other way around, so I apologize for the way this is, but it's still something then we can consider the causation for it. So as death rate goes up, our fat in the diet actually goes up as well. You'll notice that as it's going up, it is like this. So that means we have a positive correlation, because as one rate goes up, the other one's going up. And the thing is, if I was ever had a test question, I would be writing that in. No question about it. Okay, just correct the correlation. It's 1L. There we go. Okay, so that's a positive correlation. I would actually say this is I would call it weak. Now, when we're going to talk about weak versus strong, that's something that comes into the Spearman rank correlation coefficient, but really they're quite spread out. Okay, and the reason is we have this outlier here, because it is. We have quite a high percentage of fat in the diet and quite a low death rate in comparison to those with the same value. So this is an outlier, and it's something you consider if you're asked to actually analyze or describe the effect of this one here. Then actually that's one of the issues. It's the fact that without this, you'd have a very strong positive correlation because you could draw a nice, easy line of best fit. But at the moment with that, it's actually quite weak. So let's talk about how we're going to draw our lines of best fit. So I'm going to use a highlighter to show the zones. generally, I'm going to look at the top pieces of data, the bottom piece of data, and that's my first guideline. I'm going to use those to try and draw a line of best fit. After that, I'm trying to match all of the data. I think a line of best fit will go through this point here and this point here. It's not because it's in between them, but if I put a line that goes straight down here, most of the data is going to be on top. Sorry, half the data is going to be on top, and half the data is going to be down the bottom, on top of the graph and below the line. So let's try drawing it. So I draw it like this. Okay. Now you'll notice it's quite high. This is what I mean. If you just ignore this one, it's actually a little bit too high. But because of this outlier, it would actually skew the results slightly higher, which would give you this line of best fit. Okay, if this wasn't here, I would actually say it would be more like there. Okay, 1, 2, 3, almost on the line, almost on the line. 1, 2, 3, 4. Could do it like that, but it's more of an art for this. Oops. Okay, so that's how you draw your scatter graphs. That is how you are talking about what sort of correlation it is, and that's how we draw a line of best fit. We're going to look at a different one in a second. We're going to look at describing a scatter graph that's already there with a line of best fit already built in. Okay, so if you what you want to do is a question after this, you can try that one. Okay, so on the next page, right next question, we have this question here. Study the scatter graph showing the relationship between GDP per capita and the percentages of renewable energy consumption in 2015. So we've got this data here. Straight away, you can tell it's a negative correlation. That's what that line is saying. Using evidence, very important now. I'm going to highlight that. Okay. Using evidence from the scatter graph, describe the relationship between GDP per capita and percentage of renewable energy consumption. So this using evidence part we'll talk about. I'm just going to get my drawing back. Okay. So I'm back here now. So we're going to use the evidence of this to describe the scatter graph. Well, first off, as I said, what we've got is we have a, now if I look at all of this data, I would say it is a negative correlation. Okay, you could almost say it's weak because this is skewing it out. But if you look at all the other data, let's have a look. It's going to be like that. Let's say weak negative. Okay, so we have a weak negative correlation. So this is hard to get the ideas around because it's either weak, but it's definitely not strong. Okay, so we're looking at the data here and we're looking at this line and how it fits with what we've got. It's a weak negative correlation. What does that mean? So we want to describe also. So that means as the GDP per capita increases, the percentage of renewable energy consumption decreases. Okay, and you can write this down the bottom. So, and you can see that that's though I've named the correlation extremely important. Always do this. And then I've also talked about what the data is actually saying, what our axis is actually saying. Percent as this increases here. So I don't say the x-axis, I talk about what the actual values are. Increases, the percentage of renewable energy consumption here decreases. Okay. Then the rest of it is, so that's already 2 marks. Okay, 1 to 2 marks of you just doing that.